Hello, my dear friends. Today I am going to discuss GF2 matrix inverse method. Before going to describe, I have requested all of you kindly subscribe and share this video. Now start with lessons. To represent a GF2 matrix, we take a prime number, say 11, whose binary representation becomes 1011. Using this prime number, we design a 4 cross 4 matrix. To design a matrix, we use the following format. First of all, we write the prime numbers using the following patterns whose binary value is 1011. Then we apply the four circular shift operations. That is, 1 goes to the left side, then first shift becomes 1, then we write 110011. Then apply the second circular shift, that is 1 1 1 1 1 0 0. Then apply the third circular shift, that is 0 1 1 1 1 1 1. Proceeding in this way, we can design our matrix, that is 1 0 1 1 1 1 0 1 1 1 1 0 0 1 1 1. Now I describe the procedure how to find the inverse of the matrix. Before going to discuss this matrix, we can write it in this format: 1011 1101 1110 0111. We just write this matrix in this format. Then we write an identity matrix: 1000 0100 0010 0001. Then we apply the exclusive OR operations, that is, we take two values, the R3 XOR R2, that is, here is the R3 column and here is the R2 column. We apply the XOR operations. We know the XOR operations, that is, when two bits are same, the output becomes 0, otherwise it is 1. Using this procedure, we convert this matrix, that is, we write 1101, that is 1101, and 1110 110 1110. The exclusive OR operation becomes 101 101 110 110, that is, we find 0011 and we write it 0011. Again, apply this procedure: 0100 we write here 0100 0010, that is 0, it is 1, is 1, it is 0. It is the updated value. This is our first converted matrix. Then we apply the second converted matrix. We again apply the R2 equal R2 x R1. Here R1, R2, R3, R4 is the row value. There is R1 means row 1, R2 means row 2, R3 means row 3, R4 means row 4. So apply the R2 equal to R2 x R1, that is, now R2 XOR R1. We apply then 1011 1011, then 1101 1101. We apply the extra operations, that is 110 101 101 110. Apply this formula in this identity matrix: 1000 we get the result 1100. We write it in this row. This is our second, for our second matrix. Then we apply the third matrix, that is R1 XOR R3. Now I take the R1 value 1011 1011 and R3 value 0011. Then we get after applying XOR operations: 110 110 000 101. We write it 1000, and again here 1000, here write 1000 and 0110. We get this value 0111. We write it here. This is the third matrix. Then we apply the fourth matrix, fourth operations, that is R4 equal to R4 XOR R2. Then we select the R4 value and R2 value. R2 is 0110 0110, R4 is 0111. So we applying the Excel operation, we get 1 0 0 0. Here we write 0 0 0 1. Again 1 1 1 0 it takens, and 0 0 0 1 it have been taken. Then applying the Excel operation, we get 1 1 0 1. Here we write here. Then applying the fourth matrix, we get R3 equal to R3 XOR R4, that is R3 value and R4, that is 0 0 1 1 and 0 0 0 1. We write here, and applying the XOR operation, we get 0 1 0 0. Proceeding in this way, we get 0 1 1 0 0 1 0 1 1 0 1. We get 1 1 0 1. That is this matrix, this row R3 row. And again last operations R2 equal to R2 XOR R3. R2 means 0 1 1 0 0 1 1 0 and 0 0 1 0. Applying the XOR operation, we get 0 1 0 0. Here we write it, and again we write 1 1 0 0 1 1 0 0. That is 1 0 1 1. Applying the XOR operation, 1 1 1 0. Then we get the final matrix, that is 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1 1 1 1 0 0 1 1 1 1 0 1 1 1 1 0 1. Here we get an identity matrix, and this is our inverse matrix. So we get our inverse matrix 1 1 1 0 0 1 1 1 1 0 1 1 1 1 0 1. Now I show the applications, the inverse matrix using the Matlab functions. Suppose here is the matrix. We can write it in Matlab 1111 semicolon 1101 semicolon 1110 semicolon 0111. This is the first matrix. Then we write our inverse matrix in this way, and we get the value. And we take a sample matrix where we apply our procedure C 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. We get this matrix. Then I have designed a polynomial functions. This is the polynomial functions where I apply the bit or XOR operations. This is the bit or XOR operations. Now we then apply the polynomials a comma c. This is the parameters of these functions. We get the resultant matrix. Then we apply the inverse matrix polynomial b comma m. We again return back the matrix. This is a simple procedure which have been used in different cryptography algorithms, image encryptions. If you like my video, kindly share and subscribe. Thank you very much.